Hello student, welcome to this lecture number 3 of solid state physics. I hope you have understand clearly about the last two lectures which I have sent to you, even though I didn't get any response from you how this method is applicable to you, whether it's helpful or not, but I still do hope that it will help you, because this is the only option we have now, since the online classes is not possible. In the last two lectures we discussed about the crystal structure, right, from the classification of solid into crystalline and amorphous. We discussed also about the space lattice, translational vectors, which is consists of primitive and non-primitive. We also talk about the meaning of the basis in a crystal, unit cell which make up the crystal. We take the example in 2 and 3 dimension, and also a type of unit cell which consists of primitive and non-primitive unit cell. And the last we discuss about the special cell, which is called a Wigner's cell. So in this lecture we will discuss about the important topic from the crystal structure, that is symmetry operation. Symmetry operation is that operation which, when applied to a crystal structure, leaves the structure invariant. That is, the environment structure remain the same. Ini ke definition yang ke symmetry operation. The symmetry operation tak pun kawan kau ilai ho crystal. Kau pun man yang crystal hadir untuk you apply yang ini operation. No crystal man yang kapju. You kata orang ke symmetry operation. So we have 4 types of symmetry operation: the translation symmetry operation, the rotation symmetry operation, the reflection symmetry operation, and the inversion symmetry operation. The translation symmetry operation applicable to the lattice point, and it is called a lattice point symmetry operation, whereas the last 3 is called the point operation, and it is applicable to a solid crystal. The rotation, the reflection is applicable to 2 and 3 dimension, whereas the inversion symmetry operation, which is called a point operation, is applicable only to 3 dimension. Kini kisudali translational apply ke dekat lattice point ni, apply ke crystals, real crystals. Kalau ke rotation, symmetry, ke reflection, ke inversion apply ke solid body. Rotation apply ke reflection ye apply ke 2 and 3 dimension body, kan ke inversion to duka ke 3 dimensional la. Kani daw siya to imandalai ko wi den ko wi. So let us talk first about translational symmetry operation. It is the operation which, when you apply to a lattice point, you will get a new lattice point which have the same identical surrounding as the first lattice point. And that we discussed in the last 2 lectures about the translational operation, which is given by T. When you apply T, you can go from R to R dash, and this T is called translational operation. It depends upon the choice of A, B, and C. Chong ha choice of A, B kaman chimi yo no T yo primitive nai or non-primitive translational vectors. Okay, so this is the same as the one which I have discussed in the last 2 lectures. Okay. So rotation symmetry operation. A crystal is said to possess rotation symmetry operation if the crystal remains the same when you rotate it through some angle. It depends upon the shape of crystal. A crystal kanika symmetry operation tak mana rotate o crystal. Mana rotate o crystal dalam nek biang ukam jo lerman ukam jo haga angle ko rotate. It depends upon the shape of the crystal. Haga one ka angle ko de rotate. Ye kani operation anga rotation symmetry operation. M ki crystal ko mana rotate pe ruphaw dikri le man ki shape ko rim MG crystal go have rotate and they power degree, MG crystal go have rotate cheese power, R power, and so on. Kanuksa gam go square man rotate piga, happy ga rotate can they power degree or man being a gamuchu. Man symmetry being. The equilateral triangle happy ga rotate 120 degree. Okay, have rotate piga wo axis wo pass na center in ka equilateral triangle man rotate pi 120 degree. Human being kan so the operation will rotation operation. Next, number 3 is reflection symmetry operation. Crystal is said to possess reflection symmetry operation if there exists a line or a plane in which the crystal is divided into two halves which are a mirror image of one of each other. Such operation is called reflection operation, and that line which we drawn or a plane which we pass is represented by a symbol cap. Kani ka reflection symmetry operation to the pasi the droid or line. Haperdi yung crystal gawa bahai ka crystal arbanta. Kini ka atli banta man ki kami mirror image man ki mo pa yidi. The yo to line the emiti ban the emi banta iwa yo draw yo to line ha ka crystal tamad kataga crystal ang ika symmetry in reflection and rain to uro ki crystal yo draw yo mirror image em ki jajaj crystal samtam guman regular. Okay, kani ga operation ang ika ka reflection operation draw yo line ni pass ka plane la to 3 dimension pass ka plane la to 2 dimension draw yo line man draw yo line một kini da nu crystal da divide hogi arbanta higi arbanta man ki mirror image of one another. Inversion one kani apply ga 3 dimension and the 3 dimension inside the crystal there exists a point, that's why it is called a point symmetry. There exists a point, and from that point, if you consider a lattice point at the position R, then there should exist another lattice point which is identical in the position minus I. That is called inversion. Kanig inversion symmetry to apo 3 dimension crystal to any point iwa 90 point the jet P1 iwan lattice haga position R to emon iposit lattice eman haga position minus R. Okay, kalau dia apa yang kita gi lattice point ku embed ko opposite yang ki. Okay, hapo ka lattice la dia apa kita point mo yo refer pun R side la ni pun sol yang embed ko opposite one point VP embed ko opposite yaitu point could ki point of inversion. Okay, then is center of inversion. Yaitu point iwa jet ya po crystal iwa dia ba iki atli ki benta. Nanti point la jet yo R la to M minus R la jet yo S la to M minus S la jet yo atom number 2 la chen to M atom M opposite mo la dia ba igam tel M kai ti point po crystal yaitu point ko ki center of position inversion ye ka to crystal ang giga the crystal which is symmetry under inversion symmetry operation. I hope you understand about that. So let us see the diagram. Okay. So in this diagram, in this slide, we have 4 different example of 4 type of symmetry operation. Translational operation, exactly the same as what we explained in the last 2 lectures. I hope you understand. I will not go into detail about this. Okay, so here R, you go to R dash, and the equation here is R dash equal R plus T. That is called translational operation T, or translational operation, symmetry operation. Then in the reflection, we consider the notch circle. If you see this blue circle which have an opening there, okay, so if we have this kind of shape, we have a line, we can draw a line, and that line if you see here, which is called a line of reflection symmetry, that line divides the crystal into two mirror image. So this crystal is set to have a reflection symmetry operation. The same thing about rotation. If you see this shape in the form of a notched circle, it have three opening here. So when you rotate it, if you rotate it for one round, you will get three different positions where the crystal look exactly the same. Okay. I mean, if you want a crystal to look exactly the same, you have to rotate it to 120 degree. Another 120 degree, again you'll get the same. Another 120 degree, again you'll get the same. So in three position, when you rotate 360, where you get the crystal the same. Okay. Kalau debok dia ke squarean ini, ke squarean hab rotate ya so tau. Yo ai ke job baik ka dur yang square. Kalau tak ada rectangle, yo ai so tau, yo ai tau. 180 ni hab rectangle nem untuk ke job size, untuk square. Nanti tahu. That's why for every 360 degree you will get the different position where the crystal remain invariant. It depends upon the shape of crystal. So that's why we have the equation for 260 degree there will be n theta. N theta means how many symmetry where the crystal can be. How many times you will get in one rotation. So that number of time, that angle is given by n theta, where n is the multiplicity. And if you have n number in 360 degree, so that rotation is called n-fold rotation. For example, like in this case, we have three different positions. So this is called a three-fold rotation. Okay, I hope you understand it. So the next is inversion operation. MSK inversion operation. Inversion operation is 3 dimension. We take this regular shape here. It's a form of a cube. Okay, so if it is a cube, we understand that we can get inversion because in a cube there is one point which is the center of the cube. If you go to the right, and there will be, if you go to one side, for example here is R, there is another point minus R. So if you consider this point O in this 3 dimension cube, which is at the center, so through this O, which is considered as origin, all the lattice point which is lying as at this cube, it has a point which is opposite to them. Lalu dapat bihagan dengan point O, M bagi lattice point. Lalu consider O R lah M O minus R. Let's consider cai tai liang lah M O opposite yang O. Lalu consider lah M bagi opposite yang O. Nanti dah yang point O ang O center of inversion. So yang ni ga crystal ang it is symmetry under inversion operation. Kani apply ke dukat aga 3 dimension. Nadi dah aga 2 dimension mio ikam kani guman opposite. 2 dimension em ga aga xy plane. Lalu consider point here perdi you yo je through and rasa jerong si problem. That's why it is not applicable in 2 dimensional. So I hope you understand about the symmetry operation. So in the next we will talk about the combination. MG crystal gubi gula hejo ipuan. Reflection or rotation hejo ipuan. Reflection, rotation and inversion. Okay. Then let you combination yo ki jet crystal. You only crystal structure hagi 2 okay 3 dimension. So for that we will see in the next class. Thank you.